So, hello everyone, and welcome to day 2 of the SciPy Tools Plenary session. As a reminder, this is going to be a rapid series of short talks from projects, giving you updates on what they are, what they've been up to, and what their future plans are. I'm Thomas Caswell. My co-chair in this was Hannah Eisenman. And without further ado, Joris will be telling us the current state of pandas.
So you're seeing my screen?
Yep.
Okay, so yeah, I'm Joris van den Bosse, one of the maintainers of pandas. So a lot happened over the last year. We had a couple of releases, among which finally a 1.0 release. We also had some for the first time, some funding through the CDI Open Source Initiative. Also some new focus, small development grants, which amongst others things led to new getting started tutorials on documentation. Many new features, improvements, bug fixes, so I will just highlight 2 of them. And in addition, we also have a new logo. I suppose that most of you already have seen it by now, which was sponsored by Indeed, together with a new website, and also a new Sphinx theme for the documentation. So it was originally developed for pandas, but we renamed it to PyData Sphinx theme as it was started being used by other projects as well, such as Chapter Hub and Chapter Book. So if you want to use it for your own project and customize it, that's very welcome, and feedback is welcome on that. One of the new features I want to mention is some preliminary numba support, specifically for the rolling or moving window operations, and in the upcoming release also for group by. So for the rolling operation, you typically apply a function on a moving window along your data. There are some built-in fast functions like a rolling sum or rolling mean, but if you have a bit more custom operation, you can write a user-defined function. You can apply this, and then we will loop in Python, so giving quite a bit of overhead. Now you can specify you want to use the numba engine and to just-in-time compile your function, and actually not only the function itself, but the full loop looping over the different windows, calling your function. The full loop will be done in numba, so removing quite a bit of the Python overhead and giving, for this example, quite a speed up. Another new feature, experimental feature that I want to highlight is a new pandas NA scalar as an indicator for missing data instead of NaN, which is used right now mostly as the missing value indicator, but which is actually only for floating point data. So the NA scalar behaves a bit differently as NaN. For example, in comparisons, it will propagate instead of returning false. It's being used in some of new experimental data types based on the extension array mechanism. So for example, we have the nullable integer, Boolean, string data types. So you can see here in integers without becoming a float. You can see a string column with an actual string data type and not just an object data type. So these are some experimental data types. So it's not yet built in by default. So it's built in into pandas, but not used by default. You need to opt in to use it. We hope at some point, we hope to expand it to other data types, and at some point that it can become the default, but it's not yet the case right now. But so it's very welcome to start trying it out, and so we can get feedback on it and actually make it the default somewhere in the future.
And we're I was about to say we're at time. So thank you, Joris. And our next speaker is Sue, who is going to tell us about numba.
All right. Can you hear me?
Yes.
All right. So, for numba, for those who have not heard of numba, it is a just-in-time compiler that accelerates a subset of Python. And in the last year, there are more libraries using numba. They're using and extending numba. One of them, as you have seen, is pandas, using it for rolling operations. And upcoming, they will use it for group by. Another very interesting project is awkward. Not only does it use numba, it extends numba to understand their data type. They have an awkward array data type. So we also have undergone a massive refactoring effort for numba, and reorganizing code base, making it easier for new developers. And we have dropped kind of support and going to clear the code base from like a lot of the old NumPy and old Python implementation, as well as hacks. So again, making it easier for new developers to understand. There's been a lot of improvement to extensibility of numba as a compiler. You can now have library packages that are automatically loaded as a number extension. So awkward actually takes advantage of this feature. It's something that uses setup tools entry points. And the compiler is now extendable. You can create customized compiler for your specific application with our kind of new composable pipeline system. A project that uses it is by Intel Lab. They have a scalable data frame SDC container, scalable data frame container. We also have a much better error reporting system now that by default hides redundant information for typical users. And you can toggle into developer mode that shows you all the details. And we have been having a bigger and bigger community. We now surpass 1.4 million PyP downloads per month. Last year alone, we have 78 contributors, just by counting authors in Git commits. We now have an open developer meeting happening every Tuesday. Not every Tuesday, happening on every second Tuesday second Tuesday on every month. Yes, and we now have a Discord forum where we actually make announcement about the open meeting and the other discussions about the project. We're also working on a governance model to encourage even more contributors and maintainers. There are many new features in numba, and I could spend 20 minutes talking about them, but since I cannot, you can find out about all of these on our website, numba.pydata.org, and click on the Try Numba button. You can get all the live notebooks highlighting kind of features for each release. And that's it.
Thank you for being exactly on time. Up next, we have Nicholas, who will be telling us about Plotly.
All right.
We can hear you, so take it away.
Hello from Montreal, everyone. My name is Nicholas Krusten. I am the head of graphing libraries for Plotly, the company, and I'm here to tell you about Plotly, the Python package for interactive data visualization. If you don't know much about Plotly, it's part of a broader ecosystem based on Plotly.js, which is a JavaScript library, and this ecosystem also supports R and Julia. Plotly is a core part of the Dash framework for building analytical web applications as well. So since the last SciPy, we've had 1 major and 8 minor releases. The major features from the major release 4.0 were the addition of Plotly Express, which is a high-level visualization API quite similar to Seaborn. And also in 4.0, we removed any connection or relationship to external servers and services, especially those operated by Plotly, the company. So Plotly is now offline only. We've also, for the rest of the sort of 4.x releases, we've improved tile maps, so you no longer have to rely on tile servers provided by Mapbox. We've improved support for hierarchical data. You see a tree map here in the corner. We have sunbursts and tree maps with interactive drill down. In version 4.3, we added a function that works a lot like matplotlib's imshow for full color images. You see an image down here in the corner. In 4.7, we massively sped up the library and added interactive image annotation features, which was funded by the Chan Zuckerberg Initiative. And in 4.8, we added support for wide form data in Plotly Express, and we also added a pandas backend. Also, since the last SciPy, we've put a major effort in our documentation. Every documentation page has been rewritten. We have a new Jupytext backend, so it's all stored in Markdown and easy to contribute to. By popular demand, we have a Python API reference. I've got the URL here. So this is what our documentation looks like here at the bottom. You can see every page now has a new and improved search box. We have a strong focus to document our core concepts so people can feel fully empowered to use every feature of Plotly. And every page has a suggest and edit button and a launch on binder button. In terms of our roadmap, we're working on a new static image export system, which will be much easier to install than the current Orca system. It'll have no dependencies. It'll run anywhere. We're working on better Python access to JavaScript computed values in plotly.js. We're expanding Plotly Express to cover all figure types. We're working on easier ways to do common things like add horizontal and vertical lines. We're adding better support for visualizing periodic data in time series, so month by month, week by week, rather than instance in time. And we're working on closer Dash integrations for building analytical applications in notebooks. None of this would be possible without our community. Our community is responsible for over 3 million downloads a month on SciPy, so this puts Plotly in the top 300 Python packages. We have a very active community forum, over 100 new posts per week, community members showing what they've done, asking questions, answering each other's questions, so please join us at community.plotly.com. In the past year, we've had 50 GitHub contributors, only 9 of which were Plotly employees, and we're constantly working on making the repo a more friendly place with a contributing guide, a pull request checklist, and identifying good first issues. Thank you.
All right. Thank you, Nicholas. And thank you again for being exactly 3 minutes. Up next, we have Deepak, who will tell us about xarray.
Okay, can you see that?
Yes.
Okay, so my name is Deepak Cherian. I'm here on behalf of the xarray core team. And if you're wondering what xarray is, the easiest way to think of it is of pandas for n-dimensional arrays. The reason you might want to do that is because real data sets have metadata. So I'm illustrating this here with a new wrapper. And so here are all the things that go in an xarray data set. There are dimensions with names, in this case, lat and lon, and time. So lat and lon for latitude, longitude. Xarray allows you to index by coordinate labels. So lat, in this case, 88 is 88 naught. So you can use kind of logical values to index your data out. You can have multiple data variables. So in this case, there are 2 of them. And really, at the bottom of this are existing PyData objects, in this case a Dask array, but it could just be a NumPy array, a sparse array, a pint array, or a QPy array, or anything like that. And xarray also lets you carry on arbitrary metadata as a Python dict. The reason you may want to use xarray is because once you have all this metadata, you can do very nice things, very inspired by pandas again. So here you could index with nice logical labels. You could take a mean along the dimension time instead of specifying axis equals 0 and things like that. The really big improvement that has happened recently is this new HTML wrapper, thanks to Julia Signal and Benoit Bowie. And so you can see it looks great, and it also wraps, in this case, Dask's HTML wrapper, which it's just a really nice upgrade. More recently, we've made some progress on integrating arrays like sparse, pint, and other NEP18 arrays. This was actually a product of SciPy 2019 sprints by a contributor who basically made it his only contribution so far. So it was a pretty huge step forward. More recently, we've added argmin, argmax. This is a response to, I think, the most popular xarray Stack Overflow question. So now we have a one-line answer. We now have a new weighted class, which lets you do things like weighted.mean to get weighted means, which is really nice and convenient. And a really new powerful function is mapblocks, which basically, it's a little complicated, but if you have a Dask-backed xarray, you can really easily apply xarray-aware functions in parallel. So look that up. It's pretty powerful. We've also added QS, or Justice, to our maintainer team. He did a lot of work cleaning up our documentation and adding support for Pint. And finally, over the upcoming year, we were very lucky to have been awarded funding by the Chan Zuckerberg Initiative. So thanks to them and Focus for helping us with our application. And we're going to use this to make xarray a lot more flexible and really knock off these 3 things on our big roadmap. And this includes a huge improvement to our documentation. And so that's all I had. Thank you.
All right. Thank you. And again, I want to thank you for staying actually a little under time. So up next, we have Elliot, who will be telling us about matplotlib. Oh, and now while Elliot is connecting, he's connected to save me from trying to be funny in front of 600 people. So is screen sharing going to work this time?
Let's see.
It appears to be working, so take it away.
All right. Okay, I'm going to talk about matplotlib today. So in general news, we were awarded the CZI grant, and so this enabled Thomas Caswell and Hannah Eisenman to be partly funded, and myself to be fully funded for a year. And we're slowly working on getting through our backlog of many issues and PRs. We are in Google Summer of Code this year, and Gareth Bansell is working on moving our baseline images out of the repo.
We appear to have lost Elliot. Why don't we jump ahead to pull up Thomas Van to tell us about scikit-learn while we sort out our technical difficulties. Sorry. And unfortunately, I now have to be funny in front of 600 people. And Thomas has arrived to save me.
You hear me?
Yep.
All right. I'll begin. Hi, I'm Thomas. I'm a core dev for scikit-learn. I want to talk to you about the latest 2 releases of scikit-learn since SciPy 2019. Before I begin, I want to thank our contributors. These contributors make the releases possible. To begin, we have our website refresh. It's now responsive. We're also working on making the user guide even better than it is now. We have a new plotting API. It uses matplotlib, which visualizes your estimators. We have plot RC curve, plot partial dependence, plot precision recall, and plot confusion matrix. We also have stacking, which uses the predictions of estimators as features for other estimators. Stacking. We have permutation-based feature importance, where we permute features to figure out what features are important to a given estimator and given data. Histogram gradient boosting now supports missing values and sample weights. It's one of the first estimators to support missing values natively, so you could just give it missing values and it would just work. Histogram gradient boosting also has monotomic constraints, where you could give monotomic constraints to features, and it will use that constraint while it grows its trees. We also have pre-computed sparse nearest neighbors graph, in this case, k-neighbors transformer. If you combine this with the pipeline's caching feature, it computes sparse graphs, and if you want, in this case, it computes for 10 neighbors, and if you decrease the number of neighbors, it doesn't have to recompute the graph again, so which is very nice for efficiency. We have KNN-based imputation, which it uses k-nearest neighbors for imputation, as the name suggests. OpenML is a website with many data sets, and now it has an asFrame feature equal to true, which returns pandas data frames. K-means is now faster. It can take advantage of chunk size and OpenMP to make it's faster than before. So free. Yeah. We also have generalized linear models and percent loss for gradient boosting, which is very nice when you can make assumptions about the distribution of your target. Lastly, we have a HTML wrapper for Jupyter kernels. In this case, if you set the config to display equal diagram, you have an interactive representation of your pipeline in scikit-learn. So this is a very complicated pipeline, and there's an HTML representation of it. And yeah, thank you for listening, and thank you to all our contributors.
All right. Thank you, Thomas. I'm now going to remove you. So let's see if we can unmute Elliot again. So next we're going to try to do matplotlib again, but this time it is going to be a team effort as I share the slides and advance them on cue.
Okay. Can you hear me?
I can hear you.
Okay. All right, so we can go to the next slide then. Okay, so in general news, we were awarded the CZI grant. This enabled Thomas and Hannah to be partly funded for a year and myself to be funded for a full year to work on matplotlib. And so we're slowly catching up on all of our issues and pull requests. We also participated in Google Summer of Code, and Siddharth Bansal is working to move our baseline name, make it easier to progress and update them quickly. We also have a new discourse, which is hopefully possibly replacing our mailing list. And we have a new PyPI classifier framework, matplotlib, which you can use to find third-party libraries. And if you're a third-party library that happens to use matplotlib, you may want to add that to your metadata. Next slide, please. So in the past year or so, we've had about 4 or 5 bug fix releases, 1 feature release. One other thing to note is 2.2.5, which is the last release to support Python 2. And we are also in the midst of preparing 3.3 at the moment. And there's currently a release candidate out right now. Next slide, please. So 3.2 has a lot of non-visible features, but I wanted to highlight this one because it adds something to our 3D plots. And also it was made by a new contributor. So this adds a lighting source to a bar 3D, which allows you to change where the lighting is for that. Next slide, please. So in 3.3, we have a lot of quality of life improvements. So in this case, when setting a tick formatter, we maybe had to create an instance of a stir method formatter class or a func formatter class. And that was kind of annoying. So now we automatically determine that if you just pass in a string format, it will create that class for you. So you don't have to do the extra work of importing those things and creating an instance. Next slide. So AXLine for infinite lines is a nice short wrapper around making infinite lines. So with that, you can create either from a single point and a slope, or 2 points, you can create an infinite line. And this is sort of a corollary to AXH line, AXV line, but it works for infinite lines or for any slope or a direction. Next slide. So now for a really big and cool feature is subplot mosaic. And with this, we can create from a multi-line string a specification of a any layout of axes you may want. So here we have, say, A, and then a blank spot, and C, and then B that takes up 3 columns, and then D that fits into the middle 3rd column. And so then you can see we can create pretty complicated layouts just directly from that. Next slide. And then alternatively, instead of specifying a multi-line string, you can specify it as a list of lists. And in this way, you can give the names of your axes full names instead of single character letters. And so with that, you can get nice stuff. So, and then finally, on this last new feature we want to talk about is post-hoc axis sharing. And if we use the hist x axes that we had, we can call it .sharex, and then share the x and y axis that we had along those, and then they will automatically be shared. And so this can be done after you have already created the axes. And last slide, or second last slide. One last thing I want to talk about is documentation. We've had a good big refresh of our documentation. We have a new homepage. We've had a lot of pull requests in 3.3. Please check out the what's new for 3.3. It's coming very soon. We also have some cheats made by Nicolas Rouget. They were funded by the NumFocus Small Development Grant. And so final slide is our future plans. We have 3.4 coming out in September, which will be dropping support for 3.6 and NumPy 1.15. We are applying for Google Season of Docs, and those applications close on the 9th. And please check out our blog.
Right.
And one final thing I want to say, if you didn't think that matplotlib is really, really cool, I made the entire presentation in matplotlib.
All right. Thank you, Elliot. Now we're going to pull Carolyn up for our last, but definitely not least, talk of the day to tell us about bokeh.
Hi. All right. Let's share the screen. All right. So bokeh is your third plotting library of the day. Bokeh, for those of you unfamiliar, can be used to do anything from small static plots that you might embed in a document or a website, all the way up to some pretty complex dashboards and applications. I've got a couple of examples here from our user showcase where people come to show off what they've built. Some of the things that we're working on right now, WebGL, which is a JavaScript API for rendering graphics using graphics hardware. WebGL has been part of bokeh for a while. It's getting some renewed effort and interest, and we are expanding what we can do with it. Right now, it's used for some pretty basic plotting like circles, lines, and scatter plots. We are hoping with the use of Regal, a library that sort of builds on WebGL, to be able to expand this to use for use with rectangles, which should help with Dask, right? Bokeh is part of Dask. And then patches and polygons, which will help with cartographic data. The other thing we're working on right now is promoting that bokeh protocol for connecting Python and JavaScript, right? A big selling point of bokeh is that you can do these interactive visualizations without having to leave Python. Right now, that requires running a bokeh server process, which not a lot of people want to do, right? Most people want standalone scripts. So trying to bring that interactivity, that Python exclusive interactivity into that standalone script environment without a separate bokeh web server process running is one of the things that our developers are focusing on right now. So you should be able, the idea is that you would eventually be able to drop that interactive bokeh plot right into a regular Flask application that you're working with. Embeddability and portability is kind of the theme of everything that we're doing right now. We're trying to generalize and abstract some of the widgets and tools that you would use to interact with the plots so that you're not really beholden to the way that bokeh widgets do things. You could take some of those interactive plots and again, drop them into a dashboard made by another tool. You have a lot more freedom of movement there where you can embed your plots and how that works. A few random things to finish up with, we are hoping to get some CZF funding to work on LaTeX and MathTeX support. That's been asked for a while. We're trying to prioritize that. And then some backend improvements involving tightening bokeh.js. That would kind of go hand in hand with what I was talking about earlier with making that Python part independent and invisible, making the JS invisible. And then memory performance improvements that are just cleaning up evidence of organic growth in the library, just tightening things up overall. We've got a Slack channel if you're interested in helping out with the library. We have a discourse if you're interested in using the library to build things. There's a lot of helpful people there. And again, our showcase for examples, for ideas. And for release updates, we've moved our blog onto Medium, so you can find us there.
All right. Thank you very much. I'd like to thank, again, my co-chair for this session, Hannah Eisenman, and all of the speakers for staying within their time so we could get through everyone in this session. And with that, I think we're going to close the second session of second and final session of the SciPy Tools Plenary, and hopefully you will all join us in the high performance Python question and answer session, which is coming up next.